Extra example 1. Here we're finding the areas of circles and the areas of sectors of circles. So in this first problem, they asked us to find the area of this stopwatch, which is a circle. So we can go area. Oh, what is that area form? Oh, that's pi r squared. So we go area equals pi r squared. And so we can substitute it in. Pi. Oh, what is pi? Pi is approximately 3.14 or 22/7, or you can use the calculator button. So we have 1 5/8 squared, and when I square that on my calculator, I believe I get 1.625 squared. And now I can square that and multiply it by pi. And we get 5.105. And do we have units on this? There's no units. Wow, I really like it, so I'll put units squared. And moving on to the second problem, they gave us the diameter. We know the area, they want us to find the diameter. They gave us the area formula is pi r squared. And we look at this, and they gave us the area, so we can put 28.3 in for the area. And we can solve for r by dividing by pi, giving us r squared is equal to 28.3 divided by pi. And to undo squaring, we do, what do we do? We square root it. Square root both sides, giving us r is equal to plus or minus, but it can't really be minus, can it? So we can ignore that part because the radius has to be positive. And that gives us the square root of 28.3 divided by pi. And I believe that comes out to approximately 3. So that's the radius, but the diameter is equal to twice the radius, so that gives us 2 times 3, which is 6. And do we have units for that? We sure do. Come up here, it's areas in centimeters squared, so this will be in centimeters. So write down the formula, substitute what you know into it, and then solve for what's missing. Okay, to find the area of a sector in this example, which is this red shaded region here, which is a fraction of the circle, and that's 100 degrees. So I know that area of the sector is going to be one fraction. It's going to be the part we want out of the total circle, which is 360 degrees, times the area of the whole circle, which is pi r squared. So that gives us a fractional part of the circle, also known as the area of the sector. So I'm going to reduce that to 1036 just to make the numbers small, times pi. The radius, they gave us a radius as 12. So I'll put 12 squared, and now I will punch that into my calculator, and I get 126.6, and I look at the units on this. No units again. That disturbs me. Anyways, units squared. And that's to find the area of a sector. You're looking for a fractional portion of the circle. So 100 degrees out of 360 degrees. So here's another twist on areas of sectors. This time they gave us the area of the sector, RSTQ, that's the shaded region, and they asked us to find the area of the circle S. So area of the sector is going to be some fraction or portion of the circle times the area of the circle. So in this case, we have 120 degrees out of 360 will give me the area of the sector, which they told me is 48 feet squared. And the area of the circle is pi r squared. So we have the fractional portion of the circle times the circle gives me the area of the sector. And now we can go ahead and solve for r in this case. So I'm going to multiply both sides by the reciprocal, which is 360 over 120. And that gets this stuff to cancel, giving me pi r squared is equal to 360 times 48 over 120. I continue here, so that gives me 144. Then I'm going to divide both sides by pi because I'm solving for r. And that gives me r squared is equal to 144 over pi. And then I can just square root it. And then I ask my trusty assistant, Corey, what do we get? 6.76. And now we quickly look at, and we're only considering the positive, and that's the radius. Do we have any units? It's in feet squared, so my radius is going to be in feet. And that gives us the radius, but didn't give us the area of the circle, did it?